Hello, welcome to the video notes for Lesson 1-5, Comparing and Ordering Rational and Irrational Numbers. So, this lesson begins on page 26 in your notes packet. The learning target for this lesson is, I can estimate an irrational number. It's not part of the lesson target, but the other thing that we'll be doing in this lesson is ordering both rational and irrational numbers. We'll be putting them on a number line. So let's go ahead and get started. The first example says, without a calculator, locate the numbers on the number line. So there's a few different ways you can do this, and we have our number line here, and it goes from 0 to 1, and then the spaces in between are fractions or decimals, the numbers that are in between 0 and 1. So in other words, these four fractions fit somewhere in between. Now, one of the things I always do is, if I'm trying to get an idea of where fractions or decimals go, is I look at the halfway point and I say, okay, is this more than half or less than half? And when I look at these four possibilities, 1/9 is clearly less than half. 5/8, 2/3, and 15/16 are clearly more than half. So, in fact, 1/9 is really, really small. If you know anything about 1/9, 1/9 is repeating decimal. It's 0.1 repeating. And so, since that's so small, I figure that's going to be really close to 0. So here's 1/9. Also, the other thing we could do is we can turn these fractions into decimals. Now, the reason why I'm turning them all into decimals is because, or thinking of them as decimals, is because none of the fractions have a common denominator up here, so you can't really compare them if they don't have a common denominator. Alright, so we already took care of 1/9. 5/8, I know that's more than a half. Is that as much as 3/4? And it is not, because if I had 6/8, 6/8 would simplify to 3/4. So 5/8 is definitely less than 3/4. And it's basically in between 1/2 and 3/4. So I'll put it about in between, maybe just a little, just a shade less than halfway between 1/2 and 3/4. So here's 5/8. 2/3. Oh, by the way, the decimal equivalent of 5/8 is 0.625. 2/3, hopefully some of you know this one, if we convert it to a decimal, is 0.6 repeating. So it is bigger than. So 0.6 repeating is definitely going to be bigger than this. It's obviously less than 3/4. So let's just put it somewhere in between here. So 2/3. Now 15/16. Well, that's almost 16/16, which would be 1/2. So we'll say that's a little bit less than 1, 15/16. So that's how you could estimate it if we wanted to know or needed to know the decimal for that. It's 0.9375. Now remember, the learning target or lesson target was to estimate. So even though I wrote down all these decimal equivalents, you really didn't need them to estimate where these numbers went. Some people may have had trouble figuring out which one was bigger or smaller, 5/8 or 2/3, but we should be able to determine that these would be between 1/2 and 3/4. So, alright, so that's the first part of this. Let's go ahead and take a look at page 27. Estimating irrational numbers. So, estimate the square root of 33 to the nearest hundredth. Locate the square root of 33 on a number line. Now, here's how we do that. First, is the square root of 33 a perfect square? No, it is not. So we want to find the perfect square below it and the perfect square above it. So what perfect square is above 33? Well, 34, no. 35, no. 36, yes. Square root of 36 is equal to 6. So now let's go below it. 32, no. 31, 30, all the way down. Oh, 25 is the next perfect square. Now once you find either the one above or the one below, so I found 36 right away, and that, when I take the square root of 36, that's 6. You right away you know that the one below that is going to be 5, or 5 squared, which is 25. Or you can go the other way. If you found 25 first, the square root of 25 is 5. So the next number is going to be 6. What is 6 squared? 36. So the square root of 33 is somewhere in between these two. Now think about it. 33, is that closer to 25 or is that closer to 36? And the answer is it's closer to 36. It's 3 away from 36. It's 8 away from 5. So it's closer to this number. All right, so down here on the number line, we don't need to put all the numbers, but you know what? Let's go ahead. Let's go from. So we're going to need to fit 5 and 6 on here. There's 10 marks, so we'll go from 0 up to 10. Now, if we wanted to be really, really exact, we could have done this as 5 and this as 6, and all the marks in between, you know, so halfway would be 5.5. So, which is fine. Now, so we're estimating, so we don't have to be perfect. So we know that the square root of 33 is in between 5 and 6, so it's in between these two numbers. And we know it's going to be closer to 6. So I'm going to draw a line up right about a little more than halfway and put square root of 33. That's where I'm going to put my answer. Now, if I use my calculator, I find that the square root of 33 is 5.74456. Now remember, this is irrational, so it keeps on going, so dot, dot, dot. 5.7 is a little more than 5.5, so it's a little above the halfway mark. That's how you estimate where to put these irrational numbers. All right? We'll do one more together really quick, and then I will let you do the last one on your own. All right, so estimate the square root of 10 to the nearest hundredth. Locate, well, see, I don't like this because estimate to the nearest hundredth means we would actually need to look at our calculator or round it. Before we do that, let's find where it's going to go, what two numbers it's going to be between. So the square root of 10 is not a perfect square. So let's go above it. Square root of 11, no. 12, no. 13, 14, 15, 16 is a perfect square. And the square root of 16 is 4. So if I want the number, so the square root of 10 is between 4 and some other number. Obviously the other number is 3. What is 3 squared? It is 9. So square root of 10 goes between the square root of 9 and the square root of 16. Now think about it. 10 is obviously really close to 9. In fact, it's way close. So now if we wanted to, let's do this a different way on the number line. So we're going to make this 3 and this 4, and so the middle is going to be 3.5 or 3.5, however you want to write it. So square root of 10 is going to be much closer to 3 than it is 4. So I would say either this first mark or this second mark. Well, let's go with this one, square root of 10. Now, if I plug it into my calculator and find what the square root of 10 really is, we get 3.16227 ... Actually, it's probably closer to 3.2. So if you did this in pen, scribble it out, square root of 10. So this is where it goes. But we weren't that far off. It's 3.16. So it's about 3.2 or, yeah, 3. Well, if we're going to the nearest hundredth, it would be 3.16, so a little bit halfway. A little more than what we had estimated, but we were pretty close. Okay, so the next one you're going to do on your own. You're going to find the square root of 110. Before you do this on a calculator, find the perfect square below it and the perfect square above it. I'll give you a hint. The one above it is the square root of 121. Find what that equals. Then find the one below it. And then you're going to use this as your endpoints, your low number and your high number. So take the square root of these numbers, and whatever is in between is the halfway point. And figure out about where 110 is. All right? Square root of 110, I should say. Sorry. Okay, we're almost done. Let's go ahead and take a look at the next page. Now we're looking at page 28. All real numbers can be located on a number line. This means that irrational numbers can be located on a number line. You can use the number line to graph and order real numbers. Locate the following numbers on the number line. Okay, so they give you all these numbers. I want you to do the best you can to put all of these numbers on the number line. Without peeking, at the bottom of the page is the answer key. So don't look. I know I just said it, so half of you probably looked, maybe more. You're going to try this on your own. You've got the square root of 11. You know what? I'll do that one for you. Square root of 11 is in between the square root of 9, which is 3, and the square root of 16, which is 4. Again, it's going to be closer to 3 than 4. So the square root of 11 is about there. So we can cross that one off. So now you have to do the rest of these on your own as best as you can. Notice we've got some negatives, so you have a few over here, and you'll have a few over here. We're going to do the word problems together, and then we're going to be done with this video. Okay, comparing real numbers. The area of a square poster is 31 inches squared. The side length of another poster is 5.5 inches. Which poster is bigger? All right, so we've got two square posters. So let me get my tool here, and I'm going to go with square. Make it blank. Oops. All right, so I'm going to draw a square, and then I'm going to draw another square. Now, one of them is bigger. We can't tell right away, so actually I know which one is. So the area of a square poster is 31 inches squared. So I'll put this inside because it's the area. The side length of another poster. So here's the first poster. Here's the second. If we have the side length, 5.5, then we know all the sides. So you can find the area of this by doing 5.5 times 5.5, and if you do, you get 30.25 inches squared. Well, now we know which one is bigger. 31 is obviously bigger than this. If you wanted to try this another way, the other way you could do this is take the square root of 31 to find this side. And if you do that, what you get is 5.56 and some number that keeps on going, dot, dot, dot. But now that I know that it's a little bigger than 5.5, this confirms that the first poster is actually bigger than the second. So which poster is bigger? The first poster is bigger because (31 inches squared) is greater than 30.25 inches squared. Then in parentheses I'm going to say or the square root of 31 is greater than 5.5. Oh, don't forget the label, inches. So you can say for either reason, either because the total area is bigger or because the side length is bigger. Okay, one more problem. The formula, d equals the square root of 2s squared, gives the length, d, of the diagonal. That's this number here. Of a square with a side length s. Each side of a square piece of wood is 33 centimeters. You paint a stripe along the diagonal, that's this. Estimate the length of the stripe to the nearest hundredth. Okay, so we're going to just use our formula. D equals square root of 2s squared. I'm going to plug 33 in for s. D equals square root of 2 times 33 squared. So do 33 squared in your calculator, and you get d equals square root of 2 times 1089. 2 times 1089 is some big number, and I didn't write it down. So we are actually going to then take the square root of that number, and we get 46.66904 dot dot dot. So if I'm going to estimate the length of the stripe to the nearest hundredth, I'll say the length of the stripe is about 46.67 centimeters. Ding. And that's it. I know this video went a little bit long, but it's pretty powerful stuff. If you had any trouble with this, go back and rewatch the video. Good luck, and we'll see you in math.